Now that we've cached out our disintegration grain simulation, we can go ahead and start setting up the render for this. So I've created a turntable that's just a copy of our RenderCam wide here. Just made a duplicate of that and changed the keyframes on the translation and the rotation of this pivot null here, and started the animation on this at frame 95. So this disintegration shot will ultimately run from 95 to 240 and give us this nice rotation around our simulation like this. Now to render this disintegration effect, we're going to need to mix these disintegration grains with the creature as it's disintegrating. We don't want to render just these grain particles where the creature hasn't eroded yet. So back in our grain setup, after we've done our file cache here, let's delete some of those grains based on the color. So drop in a blast sop and we'll delete anything with cd.r equals 0 and set this group type to points and display that. And this looks like it's doing the right thing, but I actually also want to keep these blue particles there as well. So we're going to delete everything with a red component of the color equal to 0 except for the blue component. So I'll use the caret symbol at cd.b equals 1. So this deletes everything with red component 0 except for where the blue component is 1. So that will only delete the pure black grains there. And for display purposes in our scene, we might want to give this a color that's closer to what we'll actually be rendering. So just for viewport purposes, I'm going to drop in a color sop here and switch this to HSV and set the V component to a darker gray. And I'm not sure if the sprite attributes on this will affect our rendering of the particles at all, but I'm going to do an attribute delete just in case. So I'll connect that to the blast sop, and in this attribute delete, I'll delete any attributes starting in sprite, so type sprite star. And as usual, we're going to add a null to refer to this when we're rendering it. And I'll just call this render disintegrate points. And now let's merge our disintegration points with the rest of the creature body. So let's go up to where we're importing the creature animation, and when we're erasing part of this creature for rendering, that means the topology is going to be changing on this creature, which means we have to render this with velocity motion blur and not standard deformation motion blur. So before we start deleting anything on this creature, let's drop in a trail sop and connect that to the unpack. And on the trail sop, set this to compute velocity. And now we can compare the distance of the points on this geometry to the active grain particles. So let's pull this trail down here and drop in a blast sop, connect that to our cached out relaxed grains. Actually, I'm going to connect it to the time shift clamping just after the cache there. And on this blast, I'm just going to isolate the active red grains. So I'll say at cd.r equals 1. Group type is points. Flip this to delete non-selected, so we're only getting the active grains here. And then we're going to compute the distance from geometry. So drop in that distance from geometry sop, connect the trail to the first input, these active grains to the second. And right now this is going to give us 0 distance because the active grains don't have any primitives. So on the distance from geometry here, let's set the reference group type to points so that it can find the distance to those grain points. And you can see now our distance attribute is working correctly. And now we can delete anything that's over a certain threshold distance. So I'll drop in another blast, set the group to dist is greater than, and we'll try a value of 0.5. Group type is points. And actually this is doing the opposite of what we want. We don't want to delete things with a distance greater than 5. We want to delete things with a distance less than 5. So let's switch that in our group parameter. So now this is deleting the creature wherever we have active grains. And you can see that we are getting a few stray points here at the end, so we can clean those up with a clean sop. And by default, this clean sop will get rid of any disconnected points. And you can also check for disconnected points by middle mousing on any of these nodes here. And you can see this will give you the number of unconnected points that you have in your geometry. So that's another way that you can check that. And now after cleaning it, we can optimize things a bit by only running this distance check and deletion on the frames where disintegration is actually happening. So let's drop in a switch sop and connect the trail to that, and connect our erosion of the creature to the second input of that switch. I'll call this switch erode creature, and we're going to base the switch on the start frame of the DOP.NET. So let's go to our simulation, go to our DOP.NET here, and we'll copy this start frame parameter. And back on our switch, we'll paste in the relative reference. Then we'll check to see if the current frame is greater than or equal to the start frame of the sim. So if you look at the solid versus dotted lines on our switch, then prior to frame 95, it's not evaluating this erosion at all. It's just passing through the creature with that trail sop velocity there. And then once we hit frame 95, it starts processing this erosion here. And this process isn't terribly slow to erode this creature, but it could still be a good idea to cache this out so that it's not always processing this every time you want to render a frame. So let's add a file cache after the switch here. I'm just calling it creature erode. So then turn on load from disk for this cache here. And then we'll save out the cache for this eroded creature. And that was pretty quick to cache that out. I think it took just under 2 minutes or something like that. And we'll drop in a null after the cache. I'll call this render disintegrating creature. Now we no longer want to render this eroded creature with the others, because the other creatures we're rendering with standard deformation motion blur. So if we go into our render creatures here, we're going to want to disconnect this creature from being pulled in for rendering. So inside the render creatures geometry object, let's follow this object merge to creature flying basic. And then we can disconnect this out squid 1 because we no longer really need to display that creature or pass that to our render object, since we're only interested in that one as it's being disintegrated. And now back at the object level, if we try to display our flying creatures, they're no longer all visible because we've disconnected that one. So what I usually do here, if I want to make that creature visible as well, is I'll go back to our disintegration here, and I'll just create a merge for the disintegrating creature and the disintegration points just for visualization purposes. So drop in this merge, connect the creature and the points there, merge those together, perhaps with the gray color instead of the red and blue, like so. And now if we display the disintegration at the object level, now we can see everything nicely in our scene here. Although this creature disintegrating doesn't really match the color of the others, so for visualization, let's also add some color in here. So I'll drop in a color sop after this rendered disintegrating creature, turn down the HSV value, 0.2, do the same thing on the disintegration particles. Those particles aren't showing up quite as dark, but I'm not going to worry about that right now because this is just a viewport display thing. Ultimately, we're just going to render these disintegration particles with the same shader that we're using for the creature metal here. So now back up at the object level, I'm going to just turn off the display for the disintegration for the moment, and let's create those render objects. So if we go to our render creatures object here, let's copy that and make a duplicate of it. I'll call this render creature disintegrating. And inside here, we're going to change this object merge to point to the eroded creature in the disintegration network. So instead of pointing to creature flying basic out deforming creatures, we're now going to point this to disintegration / render disintegrating creature. And we can leave this blast in there for the eye. But we're also going to need to make this same change for the eye light object we're using as well. So let's copy this object merge for this eroded creature here, then go to our light creatures object and dive inside there. And in this object, if we hide other things, this is where we're just isolating these eye meshes that we're using as light sources in the scene. And because we disconnected that one creature from the other two as far as the render reference goes, we're no longer getting the eyes for the creature that's disintegrating. So let's just copy in that object merge for the one that's disintegrating as well. So paste in this disintegration eroding creature, merge that with the others, and now we have the eyes for all three creatures here. And then for the creature that's disintegrating, these eyes will just disappear as the erosion overtakes that part of the geometry. Yeah, it looks like those eye meshes are popping off right at about 144. So now back to the render object for the creature that's disintegrating. I mentioned before that we need to render this with velocity motion blur instead of deformation blur. So if you select that geometry object and go to the Redshift tab, then under render and scroll down, you can turn on mesh deformations blur from velocity attribute. So turn that on and this will default to the V attribute for velocity, which is correct. And aside from that change, everything else remains the same as the other render object for the creatures. And now let's make a copy of this render creatures disintegrating for the actual disintegration particles. I'll rename this to render disintegration points, and a lot of these settings will be the same. I'm going to leave this RS creature metal on these disintegration points. We're going to leave this setting where we're using the mesh blur from velocity attribute V, and the only thing we need to change here is on the Particles tab. Go to that and select Render Object as Particles. And these particles will use the P-scale attribute to determine the size of them, but if you want to, you can use this global scale multiplier here. But we're just going to keep the P-scale that we actually simulated, and then inside this render disintegration points, of course we need to point this to the actual particles because we just made a copy of the eroding creature, so we can just delete this eye portion here. We don't care about that for the disintegration points. And this object merge, I'm going to point to object disintegration / render disintegrate points. And now you can see that we're getting all of our points here. And this color on these points won't really affect anything. You can put this color information into an AOV if you want to. It's up to you if you find that useful. And now that we have these objects set up, you can just add these disintegration points and the eroded creature to your Redshift render ROPs as normal, and then kick off some beautiful renders. And now these frames are my more finessed and composited final disintegration shot with all the other elements in there. But in any case, your rendered disintegration elements should look something like this. And with disintegration effects, you could certainly add in some extra dust layers. It could look really nice to have some volumetrics emitting from these disintegration particles, but at the moment we're just focusing on grain sims here. So it's up to you if you want to finesse this further and add some extra dust coming off of these grain particles once we get into the volumetric simulations later. And I should also mention that This grain sim resolution is much higher res than what we've currently been simulating. I believe this uses a grain particle separation of 0.1, so this is many more points. And it's up to you if you want to try running something this high res for this week's material, or if you want to save this really high res simulation for after we apply the nice tentacle animation on these creatures.